In this tutorial, I am going to discuss about the polymorphism, one of the very important concept of core Java. In the polymorphism, because when we start the polymorphism and after the polymorphism, most of the topics which is there, that is based on the polymorphism itself, right? So, what is first of all polymorphism? If I'll ask you what is the polymorphism? So, polymorphism is one form behaving differently in different cases is called as polymorphism, right? One form behaving differently in different cases called as polymorphism. You can take any example, like suppose you can consider a TV remote. In TV remote, suppose red button is there, on that the red button task or behavior keep on changes. That is according to the requirement, right? According to the requirement, which means what? Like if the television is on, that time it is used to switch off it, and if it is off, then it is used to switch on it. So that is like one, you can say one example I have given for the polymorphism, right? Now the polymorphism which is there, this is mainly of two types. In that, what are the two types of polymorphism it is there? Polymorphism is of mainly two types. In that, number one, which here is there, is the compile time polymorphism. Compile time polymorphism, or you can say static polymorphism. And the second one which we are talking about is the dynamic polymorphism or runtime polymorphism, right? Now see, in my last tutorial, what we have seen is about the compile time polymorphism. We have seen that we were achieving by method overloading. We were achieving this by using the called as method overloading. Fine it is now. So that we were achieving and that we have seen. So in order to understand compile time polymorphism properly, you just go through the last tutorial of method overloading, right? Now when I am coming to the dynamic polymorphism, so first of all, what is the dynamic polymorphism? See, again, if I'll say dynamic polymorphism, so again I'll be repeating the same point, like one form behaving differently in different cases is called as polymorphism. But here, in the case of dynamic polymorphism, the method behavior which is there, that gets changed according to the requirement, which means, so see, first of all, in order to achieve the dynamic polymorphism or runtime polymorphism, with two things which is very important. The number one thing is what? Now suppose, like now here I am saying dynamic polymorphism. So in that, the two things are very important thing. Number one, what is that number one dynamic polymorphism in the case? Like method overriding, and the second option which we have is the dynamic dispatch. Now if any one of them, then you will be able to achieve the runtime polymorphism or dynamic polymorphism. Fine it is. Now say, we just need to concentrate now, what do you say about method overriding? What exactly is the method overriding? If any time or whenever I say override something, override which means something existing was available, now that has been overridden by something new one, right? So that's what we will call it as a method or anything override, something we have done overriding, right? Means something which was already available, on that we have imposed something else. So the previously which was there, that was not visible after imposing that, right? So that is what the method overriding is. Now here, in order to override any method whenever we are overriding. So see, I'll be coming to the dynamic dispatch later on, but first I'm discussing overriding of a method in a proper manner, and then we will discuss the dynamic dispatch, and then by combining both we will discuss the runtime polymorphism, how we are going to achieve. One more point you can understand, like runtime polymorphism which is there, we can't achieve runtime polymorphism, we can't achieve by static properties inside a class, like static method, we can't achieve with that. In order to achieve the runtime polymorphism, we always need the instance properties of a class. If instance properties are available, with that only we can achieve, or else with the other things we cannot achieve on that, right? So first, when I'm talking about that is method overriding. So first, what is the method overriding? Everything I'll explain programmatically also, but here now just going through that before starting the programs, I'm explaining you in this manner. So suppose we are writing a class, for example, what we are writing a class, and that class we are writing as an maybe animal class. I am writing one class animal I have written here, right? When I am writing a class animal, so see here now in this we have void of eating. In the eating, we have some implementation inside the animal class, and parallelly another one which I am going to write, void of sleeping, that is some implementation is there. And now one more implementation or one more method I am going to write, void of now walking method. When I am writing, this is also some implementation I have written here, fine. Now see, what is the need to override a method? Now see, animal is a very big category. In that, all the animals, 2-3 things are mandatory about the animals. Animal will, any animal, if it is, that animal is going to eat something in some way. It is not defined like what way it is going to eat, but in some way it is going to read the or eat. It is going to sleep also, and that animal is going to walk also. But the walking style, eating style and sleeping style could differ from different animals, right? So in that, when let's suppose we are writing a class called as dog, which extends, what it extends now, which one now? Animal it is extending here, right? Now when it is extending the animal inside this, so see, the dog could eat in a different manner. So we must have to write the same signature here. What is the available, the signature which is available here, we must have to write the same signature. We should not do any changes in this, right? So void of, what is that now? Eating we are overriding here, and we are writing our own implementation according to the dog, right? So in the case of overriding, when you wanted to change some implementation of a method, you can override it inside a class, inside your subclass. Second thing, when you wanted to use superclass implementation as it is, which is available here, right? So if you want to use this implementation itself, right? So no need to override it inside your class. Third one, like walking method. If you wanted to again write the same implementation, you can write it, or else you can use the superclass implementation by using the super keyword, right? So if walking method which is there inside the dog class, so dog class you can override it. In case if you want to use superclass implementation, you can use it. But when we talk about the access modifiers, when we talk about access modifiers of a method, right? So access modifier, for that there are certain rules. What all the certain rules are available with the access modifier? So when I am talking about access modifier, so see here now, one diagram I am drawing to you first. In that, we are writing here what now? Superclass, and here what we write is the sub class, fine. Now when we superclass, if your superclass method access modifier is the what now, if it is private, then if you are writing same method inside subclass, so you can write anything, like suppose here again default, protected and public. So when I am writing this, so if it is private, then inside the subclass, if you are writing same method, so you can write anything, like you can write private, default, protected, and you can say it is a public, right? Although we don't say that this method means, what we say that the private method can't be overridden. It cannot be overridden. The private method which is there, we cannot override that method. At the same case, when your superclass method is default method, then the subclass method could be default. Default, which means if you will not write anything, then it will be a default. It could be a protected, or it could be the public, anything it could be. If the superclass method is protected, then it could be the protected and which one now? Public. And if the superclass method is public, then it has to be the public itself. Means the subclass over method which you are overriding is the public itself, right? Now then again, 2-3 points are there. Number one point is static method cannot be overridden. Static method cannot be overridden. Second one, final method cannot be overridden. We cannot override final method also. And third option is what we are going to write is the private method of a class also will not be overridden. Actually, there is something like overriding of a method, which means first of all private method will not be visible itself to the subclass. So we can't say like whether we can override it or not. So somehow we consider that a private method also of a class cannot be overridden. Is that okay now? So that is one in short overriding of the method I have explained here. Like what is the method overriding, what is the way to override the methods, and what are the things we should think or while take care in mind while overriding this method. Is that okay? Now again, there is a concept called as dynamic dispatch, because when you are overriding a method, so it's in what is that now? This method is the this is the access modifiers which we are using. So method overriding is this, and now we are going to learn the dynamic dispatch, because if you are just overriding the method and you are not trying to achieve the dynamic dispatch, then you will not be able to even achieve the runtime polymorphism, right? So here again, in this case, I am writing something here. What I am writing here, see that, understand here. What is dynamic dispatch first? If suppose if I will ask you, I am writing a class A and another class I am writing class B, right? In that classes, some things which we are going to do. What we are going to do now? The number one I am writing A of A1 is equal to new of A. Can I write it? Yes, we can write it, no issues. Fine. Now next one, the second one when I am writing, that is A of A2 is equal to new of B. Can I write it? See, by seeing the current scenario, we can't write it, because there is no relation between class A and class B. Fine, I will come to that point, I will try to correct that points, but as such we cannot write it. The third option which I am writing again, B of B1 is equal to new of, what is that I am writing next? B, right? So B of B1 is equal to new of B, easily we can write it, no issues. But when we talk about the fourth case, so B of B2 suppose is equal to new of A, this also we cannot write it. Fine. Now, what exactly we are trying to achieve, or what exactly we are trying to do? So, see, when we could do this operation, so see what is dynamic dispatch? I will tell in one line. Dynamic dispatch is the process of assigning subclass object reference to the superclass reference variable. Dynamic dispatch is the process of assigning subclass object reference to the superclass reference variable. Again, inside that, so see, if I will write here extends which one now? Class A. If you write this, now there is this, we can call it as an super class, and here what we can call it as an, that is the sub class. So, this is super class, this is the subclass what we have, right. So, if the super class and the subclass what we are writing, so now see, according to the definition just now what I have told, that dynamic dispatch is the process of assigning subclass object reference to the superclass reference variable. So, this is superclass, this is subclass. Since it is a subclass, so this is the subclass object reference which we could assign to the class A2. Can we do it easily? Yes, we can do it. Now it is okay. There is no issue with that. Fine. But again, now here this is the superclass, and the superclass things cannot be assigned to the subclass. This is not possible. We can't do this. We cannot do this. Now, another options, some more things I will write and I will explain about that. Like suppose when I am writing B3 is equal to, can I write, see, A1, A1C. A1 is a superclass reference variable which contains superclass object reference itself. So, if we are assigning this to the subclass, we cannot do again. We can't write it. But again, it will throw one exception, that is java.lang.classCast exception. Java.lang.classCast exception it is going to throw. So, again, when I talk about the sixth one, again, here B of B4 is equal to, what next I am going to write now? B of B4 is equal to, I am writing A2. When I am writing A2, so B of B4 is equal to A2 I am writing. So, A2 what it contains now? A2 which is there, what it contains? It contains super subclass object reference. So, see, directly we cannot do in this also, but if we try to do that, B of B4 is equal to, we are typecasting to the which type now? A2 type. Somehow the typecasting is always being done on the basis of content, right. So, content of A2 is what? B type, and lastly we are going to typecast it to the B type. So, we could do this option here, right. But similarly, when you try to do it here, like B of B3 is equal to, here B of something A1 we are writing, we cannot do it. Then it is now. So, this is what we will call it as a dynamic dispatch. Fine, it is now. So, this is dynamic dispatch, and method overriding just now I have shown you, right. So, now by combining both, now we can achieve the runtime polymorphism in that case, right. Here I will write some examples to show you. I will just explain you one basic things about this. Like suppose I am writing here, I am not using projector here, I will just write one small example to show you about what is the method call, what is the other behaviors, and other processings are going to be done. Here when I am writing, see, I am writing a class A, done, fine, can I write it? Here in that I am writing one word of M1 method, can I write it? Some implementations I am writing, right. Similarly, I am writing here static void of which method now I am writing? M2 method I am writing. So, a class A contains M1 method and which one now? M2 method, which is in static. So, with the help of static we cannot achieve runtime polymorphism, because static things supports early binding, whereas instance which is there that supports late binding. Now, you have to make it clear what is early binding and what is late binding. So, again when I am writing another class, class B which extends class A. In this now, what next I am going to do, I am writing void of M1. So see, I will be overriding void of M1 method as it is. I am overriding it, right? I am overriding it. Now see, here also if you want me to write, so see, if it is a static method and you wanted to write same method inside the subclass, so you have to write this static also same signature as it is. So I am writing static void of which method now? M2 method I am writing here. I am writing M2 method, okay, right? So when I am writing M2 method inside this, so this is also available. Now see, I am doing what I am writing now. See, the number one, A of A1 is equal to new of A I am writing. So see, when we call any instance method call depends on the content of the reference variable through which we are calling, right? Whereas in static method call depends the type through which we are calling, which means if see here now first, if in case of A1, if I'll ask with any one of you can answer it, if A1 dot M1 method I'll call, which class implementation it will call, either A class or B class? Definitely A1 contains A class object reference, so it is going to call A class implementation itself. When A1 dot which one I am calling M2 method, so see, it is also going to call A class implementation itself, fine. Whereas in the next case, second option, A of A2 is equal to new of I am writing B, see, means superclass reference variable contains which one now? Subclass object reference. So when superclass reference variable contains subclass object reference, so I am calling here what is that? A2 dot which one now? M1 method I am calling. So it checks first, what it checks, that M1 method signature is there inside M1 superclass A or not. If you are calling any method and that method signature is not there inside the superclass, right, and through you are calling any method through the reference variable, superclass reference variable which contains subclass object reference, and if that method signature is not available inside superclass, then it will give some error, which means like suppose you add one method here that is void of M3 method you are writing here, some M3 method you are writing here, right? So after writing the M2 method, see, if you call here A2 dot M3 method, so see, it will search whether M3 method signature is there inside class A or not. If it is not there inside class A, so it will give you the error. It will give you error, that is cannot find symbol M2, right? Whereas when we talk about next, when you call A2.M1 method, so it checks whether M1 signature is there, it's there. Then it will search whether the implementation of M1 method is there inside subclass. If it is there, it will call this, means subclass implementation it is going to call, which means inside A2, which class object reference is available? B. So if you call any method with the A2, that is instance method if you are calling, and if that method signature is available inside subclass, so it will call from subclass itself. Clear, right? Then again, next case, when I am calling A2 dot, what is that now? M2 method. So as I told, M2 method call always depends on the type through which you are calling. A2 is what type? A type. So without thinking anything, it will go directly and it will call M2 method from the class A, because it is a static method. It will not call the subclass implementation. Is it okay? So something about the how it is going to work and all other basic things about this here I have explained, and hope you can understand on the basis of this what exactly and how exactly it works.